My handwriting is even worse on this board, so I apologize in advance. And these are all things that can be done on Desmos, so we'll do that. For this first one, if we were to type in the two ordered pairs, and then if I were to count these, I'd be going down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And that would simplify to negative 2/3. So make sure you have m equals if you did the work in Desmos or counted it. Make sure you use Desmos, bless you. The further away the points are, Desmos gets a little tricky to use because you may miscount. Something to kind of help with that is if you go into the settings and change the step value to 1 for both of these. Actually, that's fine. And it was something else. No. Oh, it was something else. Then anytime you zoom in or out, you could, that didn't work. Whatever I just did wasn't it. I'll figure that out. But usually when you do that, you can see all of the numbers no matter what. Hold on one second. And then for number 2, this is a line of best fit problem. So we need to find the line of best fit. So then I can kind of see my line of best fit, and it doesn't ask what the line of best fit is, so you don't have to write that part. But it does ask which is the closest to the length of time it should take Marsha's 6-year-old niece. So we know the ages are our x, so if I put in x equals 6. Oh, also I skipped a step, so backtrack on that. I was supposed to type in the line of best fit equation first. Okay. So y1 tilde mx1 plus b is always going to be your y equals mx plus b, but in your table you have x1 and y1, so that you get that line. And then once you have the line, then you can type in your x equals 6 and find where those two lines cross. which would be at 199.519. The closest would be at 200, so B. And as long as you said you did that in Desmos, you don't have to put the rest of that work. Questions on those two? Okay. And number 4, write an equation passing through the point. So I could put in this point, put in the given equation. And then count the slope of this. So it looks like we're going down 1 to the right 5. And if I need something that's perpendicular, I'm going to type in y equals mx plus b. Add in all my sliders. Change my m to be the negative reciprocal of negative 1/5, so positive 5 over 1, or just positive 5. And then move the b value until it goes through that point. At negative 7. So the equation would be y equals 5x minus 7. And again, if you did that in Desmos, make sure you have used Desmos. Just in case you missed that. Okay, we're going to quickly go through the SOL practice. We may have to finish some of that when we get back, but we'll start it. So all of these could be done in Desmos. Most of them were slope or writing equations. You don't have to write down all the work, as it can be done in Desmos, but make sure you have the answers. For number 1a, the slope was negative 3 over 2. Number 1b, the slope was 4 over 3. And c was positive 2. The slope for number 2 was 1/2. For number 3 was 1. And then number 4, the slope was negative. And then go on to that next page. Number 5, the slope was negative 4. 6, the slope was negative 3/5. For 7 and 8, you had to plot 2 points on the line, so you could have put that into Desmos and just found 2 points. The 2 points I have for number 7 are 0, 2, and 3, negative 2. For number 8, 0, 5, and 2, 2. So again, make sure you have the points. The work is not necessary. For number 9 through 15, those were all finding the equation. So you could have used Desmos, used your sliders to adjust those and find those. Number 9, the equation was y equals negative 2x plus 6. Y equals 4/5 x minus 3. 11, y equals negative 3/5 x plus 3. And then I'll show 12, and then we'll stop there for lunch. 12, it asked you to find a line that was parallel, but the line ended up being the exact same, so they wouldn't have been parallel. Y equals 2x plus 4. So on this last page, write these answers down.
I like my comments. I want to say it.
Okay, hold off on that. For 13, the equation was y equals negative 1/4 x plus 9. 15, y equals 3x minus 17. Sorry, that was 14. And then 15, y equals 1/5 x minus 4. The sections that are due next week, on Monday when I see you again, are all of A6C through A7D. But only parts of those will be formative because there are some that we haven't done yet. So the ones that are formative are A6C, A7C, and A7D. So the 2 C's and the 1 D section. Make sure you try all of them, A6C through 7D, but just the 2 C's and the D section are the formatives. Questions on that? Really quickly, I'm going to show some of these in Desmos. So all the ones that had equations that asked for the slope, you could just graph that and then count the slope of those lines. And that was a few of these. Anything that had points, put those in. You can put them in the same line or in separate, and then count the slope. The 7 and 8 where you had to plot the points, you can look at the line, plot any of those points, any 2 points that would fit. I don't have mine up here for some reason. For all the ones that asked about equations, if you put in the ordered pairs, put in the equation given if there was one. The first few, you were given the y-intercept, so you could move your b to your y-intercept, and then move your m slider until it goes through that point. And then you could do that for any of these other ones. The parallel and perpendicular ones, you would need to put in the point, put in the equation, put in another y equals mx plus b, and then change the sliders there. Okay. Bless you. So today we're going to talk about the last type of factoring there is. So as a refresher, we talked about, bless you, GCF, difference of squares, factoring trinomials when a equals 1, and factoring by grouping. And this is kind of be a mixture of all of those, maybe not difference of squares, but most of those. So I'm going to talk through the rule or the how to do this first, and then we'll do some actual examples. So with all of these problems, make sure you're looking for a GCF, because that might help you in the beginning so you don't have to worry about bigger numbers later. Then we're going to multiply A and C together. So just the numbers, not the variables, multiply A and C. Find whatever that would be. Max, make sure you're writing this down. Whatever factors you could find from that, those are going to add to be B. So that part is similar to the trinomials that we learned about before spring break. And then from there, we're going to take the two numbers we found, rewrite our trinomial into a polynomial so that it has 4 terms by removing the middle term, putting the 2 new terms that we found, and then we now have 4 terms so we can factor by grouping, and then all of those rules. So the boxes you have on your notes are kind of small. You may want more paper or write it on your desk and then transfer it over to your notes or something else. So we're going to start with example 1. Does this have a GCF? Is there something we could divide out of each one?
Yeah.
What? Could I divide 2 out of these 2?
No.
No. So the GCF here is just 1. I'm just going to write that off to the side just so we remember we did look for a GCF. It just didn't have one other than 1. It was prime to begin with. So then multiply 2 and 3 to get 6. Find factors of 6. What would give us 6? 2 and 3. And 1 and 6. And then of those, which ones would add to be 5? 2 and 3. So we're going to take this and rewrite it. The first and the last stay the same. So we'd have 2x squared. And then the 2 new numbers we just found. It does not matter which one you put where. You can use the 2 first or the 3 first. I'm going to just do it in the order. So 2x plus 3x. And then the last term, plus 3. After you split this into the 4 terms, now we're going to factor by grouping. So all the rules that we talked about before on how to do so, we're going to use that. Split it down the middle. Look for what did those first 2 have in common. What would the GCF there be? 2x. We're dividing 2x from both of these. What's left? X plus 1. And then what could we divide out of the last 2? Positive 3. Make sure you bring down that sign, leaving x plus 1. And then at the end, the outside terms come together. That was supposed to be a different color. So 2x plus 3, and then x plus 1. If you wanted to check yourself, so this next step is optional, but you can use it, you could distribute this back out using box method, FOIL, double distributive. So 2x times x would give us 2x squared. 2x times 1. Positive 2x, 3 times x, positive 3x, and 3 times 1, 3. And if I combine my like terms, we have 2x squared plus 5x plus 3. That's the original, so I know that works. So you could always use this to double check yourself. What questions do we have so far? Let's try example 2. Does that one have a GCF? No. Other than 1. So then multiply 5 and 6. 30. And we're looking for factors of 30. I'm going to write that over here. What are some factors of 30?
3 and 10.
3 and 10. I heard 1 and 30. 15 and 2. 5 and 6. And I think that's it. So of those, which ones could we add or subtract together to get negative 17? 15 and 2. But how could we make it negative 17?
2 minus 50.
They both need to be negative, correct. So then rewrite this. First and last stay the same. 5m squared. I'm just going to leave some space. Write my plus 6. It doesn't matter the order, but I know that 5 goes into 15, so I'm going to put those together. But if you don't do that, you'll still end up with the same thing. Split that down the middle. What do those first two have in common? 5m. And if we divide that out, what's left? M minus 3. What about the last two? Positive 2 or negative 2? Negative 2. Leaving us with m minus 3. And then our two factors would be what?
5m squared.
Not squared.
5m minus 2.
5m minus 2 and
M minus 3.
m minus 3. Questions on anything there? There's a lot going on. So once you get the hang of this, it gets easier. The steps get more memorable. Basically, the grouping part you know already. It's just how do we get there is what you have to remember. All right, let's do example 3. Does that have a GCF? No, other than 1. Could I divide this 5 by 2? No. So then multiply 6 and negative 4. Negative 24. But I'll just put 24. And then find factors of 24. I heard 6 and 4. 3 and 8. I heard 12 and 2. 24 and 1. 1, 2, 3, 4, 5, 6. That's all of them. Okay. And then which of those, if we added or subtracted them together, we get negative 5?
8.
Negative 8 and positive 3. There we go. So then rewrite this into 4 terms. First and last stay the same. And split that down the middle. Find the GCF. What would that be of the first two? 3y. What would be left? Y plus 1. I'm sorry, not just y, but 2y. Okay. And then of the last two? On the inside, that's what that'll be. But what do we divide out? Negative 4. So then our two factors are
3y minus 4. And then
One of those is a y, one is a 4. Any questions there? Yeah, we're going to do one more example together, and then I'm going to have you guys try some. So in example 4, does that one have a GCF? No, other than 1. And then if we multiply 12 and negative 5, negative 60. So what are some factors of 60? There's a lot. 2 and 30. 1 and 60. 12 and 5. 10 and 6. 10 and 6. I'm trying to remember everything you guys are saying. That's supposed to be a 10. Someone else just said something. 15 and 4. 15 and 4. Pretend there's a 5. I'll erase it and fix it when I go back. Okay. So we have 1, 2. What about 3? 3 and 20. 4, 5, 6. No 7, no 8, no 9. So that works. And which of those would add or subtract to be 11? Correct. 15 minus 4. Yes. So rewrite this. 12c squared. Doesn't matter which one you put first. Let's say I put plus 15c minus 4c. And split that down the middle. What do those first two have in common? 3 and c. What's left?
3c minus 1. 4c.
There you go. 4c.
Oh, I'm sorry.
It's okay.
I
Plus.
did it differently on that.
Someone said it, but I didn't hear it. 5. If you wrote it the other way, you should still get the same answer at the end. And then what could we divide out of these two? 1, but negative 1. Leaving us with 4c plus 5. All the signs were changed. And then our two final factors.
3c minus 1.
Correct. That works. Alright, so for the next 9 problems, each table is going to do one problem. If you finish that one, you can try some of the others. After you finish that, you guys can work together as you're working through it. You can work separately and then see if you guys got the same answer. After I give you time to work through that problem, we're going to talk about the answers. And then if there's any that we need to solve completely, we'll do that. And then move on to one last thing with us. 2 last things with us. So make sure you're paying attention. You guys are going to be number 1, 2, 3, 4, 5, 6, 7, 8, 9. So find the number that I just gave you and do that problem. Alright, number 1. What do you guys got?
In parentheses 4x minus 1 parentheses and then parentheses x plus 5.
So did you both got? Do you have any questions? Okay. You all should write down the answer. That way later you can go back and redo the work. If there is one that we want to see, we'll do that after I get all the answers done. Number 2. Okay. So let's work that one out. Does this one have a GCF? No. Other than 1. Okay. If we multiply 6 and 2, that will give us 12. So we're looking for factors of 12. I'm just going to write them this way. What times will give us 12? 3 and 4. 6 and 2. 1 and 12. So of those, which ones would add to be 7? 3 and 4. So we have 6k squared. I'll just put plus 3k plus 4k plus 2. Split that down the middle. What could we divide out of those first two? 3k. And what would be left? Plus 1. And what could we divide out of the last two? 2. Leaving 2k plus 1. And then our final answer, 3k plus 2 and 2k plus 1. You guys figure out where you went wrong. Okay. Number 3.
2y minus 1 and 4y plus 3.
2y minus 1 and 4y plus 3. Did you both get that? Any questions there? Okay. So make sure you have that written down, and then we'll go on to the next page. Okay, group 4.
I got 1w minus 10 and 3w plus 1.
Hold on 1 second. My board decided to do something weird this time. Okay, one more time. W minus 10. No. Why are we not working? Okay. Once more. W minus what is happening? Okay. I'm just going to put it up here. W minus.
Minus 10
This is for number 4.
and 3w plus 1.
Did you both get that? Do we have any questions there? Okay. I don't know what these happen, but let's hope it works better for 5. I'm going to be fancy today. Alright, 5. Okay, so let's work through that. Well, let me see what you guys got, and then we'll work through it.
Oh, I did my math one.
Okay, so did you get part of the answer?
No.
Okay.
I got 5p plus 2 and 2p minus 1.
So don't write this down yet. 2p plus
2p minus 1.
minus. Let's see if that works. Okay. Doesn't have a GCF other than 1. 10 times... It's just something about that part. Okay. Would give us negative 20. Factors of 21 and 20, 2 and 10, 4 and 5. The ones that would add or subtract to get a negative 1 would be negative 5, positive 4. And then if we split that down the middle, we'd have 5p, leaving us with 2p minus 1, and then plus 2. So it looks like you're right, Jackson. So 5p plus 2, 2p minus 1 was that correct answer. Okay. Number 6. you got?
Yeah.
Okay. Do we have any questions about that? Do you guys have questions about that? No? Okay. All right, number 7. A plus 1. So I'm going to write that as 2a plus 1 squared. That would be the same thing. Did you both get that?
I got a 2a plus 1, 2a minus 1.
Okay. So let's check that. So GCF is 1. This will give us 4. Oh, cool. The board is just has a mind of its own today. Factors are 1 and 4, 2 and 2. So we'd have 4a squared. This would be negative 2 minus 2. Plus 1. And then you split that down the middle. We have 2a. Okay. Leaving it with 2a minus 1. And then if we take a negative 1 out of that one, 2a minus 1 again. So it should be 2a minus 1 squared. So you were close.
Taking negative 1
Out of this one? So whatever is first, so in both terms, this or this, if either of those was negative, take out the negative first. Take out the negative with it. Okay, 8.
2x minus 1 and x plus 9.
X plus 9. Okay. Is that what you both got?
Yes.
Yes. Questions there? No. And then number 9.
2x plus 3 and 3x minus 4.
What x minus 4?
3x.
3x. You both get that? Yes. Do we have questions there? Okay. Do we have questions about any of these in general? All right. Look at the lower part. So sometimes you'll see problems, or you may not know it, but you may have a problem with a GCF and have to do all the stuff we just did. If you see bigger numbers, that should tell you there might be a GCF there. So in number 10, still look for a GCF first. Is there something we could divide out of each? 2 works, but there might be something higher. 4. And if you're not sure, you could list out each one, put the factors of each one, use the GCD in the calculator, but only 2 at a time. And then you have to do it again for the final 2. Or you could think about the factors of 20 or 24. Think about the highest. 5 wouldn't work for everything. 4 might work. Start dividing it, see if that works. But 4 is the GCF. So we're going to divide everything by 4. What would be left?
5 and negative 13. Negative 13 and negative 6.
And then everything else we just did is going to be the same. We're just going to keep bringing down that 4 on the outside. So then, no more GCFs, multiply 5 and negative 6. Okay, I'm not trying to erase. Sure. To get negative 30, find factors of 30. And I'm actually going to stop at 15 and 2 because that would work, but we could list out the other ones. So if I had a negative 15 and a positive 2, that would give me a negative 13. So let's rewrite those. Keep bringing down that 4. That was supposed to be 6. I will be so happy when smart board gets fixed. Okay. And then split that down the middle, find the GCF of both sides. 5n, yes. Leaving us with it would be 3 on the other side. What would be left here? Just n. Keep bringing down that 4. I didn't for a second. And then what would be left? What would we divide out of those two? Positive 2. What would be left? That was a 2. It was supposed to be. I have 0 idea. I don't use this board enough to even know that. So then I'm just going to write this down here, but you would have 3 factors. 4, 5n plus 2, and n minus 3. And that would be your final answer. Any questions there? Look at the other ones, 11 through 15. Are there any others we want to see, do, go over, have questions about? So, reiterating, if you see big numbers, there's most likely a GCF, do that, find the GCF first. If you don't find the GCF first, and let's say you just started multiplying 20 and 24, you're going to end up with some big number, then have to find the factors of said big number, that add or subtract to get 52. So you could do that, it will work, you just have to be careful because those are bigger numbers and you may make more mistakes with that. And then at the end, you'd have to divide out the GCF. So it doesn't matter. Somewhere where you have space, it could be on this page, on the back on the front, I want you to write this down. X squared plus 2/3 x plus 1/9. Somewhere where you have space, write that. And this is a different type of trinomial that you would have to figure out how to do. When you see something like this, we don't want to leave these fractions in here. We want to get rid of them. So whatever this denominator is, you're going to multiply the entire thing by that number. We're going to multiply the entire thing by 9. And that's going to change all the values. So this will give me 9x squared. What's 9 times 2/3? And then plus 1. So then it looks like a trinomial that we were just working on. So let's do this, and then I'm going to show you something about the end result. So 9 times 1 would be 9. Factors of 9. 3 and 3. 1 and 9. Of those, which ones would add to be 6? 3 and 3. So we'd have 9x squared plus 3x plus 3x again plus 1. Split that down the middle. What would those first two have in common? 3x. Okay. What would be left? 3x plus 1. Okay. And then what could we divide out of these last two? 1. So if nothing else, always 1, leaving us with 3x plus 1. So we end up with 3x plus 1, 3x plus 1, or 3x plus 1 squared. Yes. Yes. And then I'm just going to show something about the answer. If you saw a problem like this and you immediately jumped into your factors, let's say I'm thinking of two numbers that multiply to be 1/9 but add to be 2/3. Well, 1/3 and 1/3 would work. Because if I multiply these together, I would get 1/9. If I add them together, I would get 2/3. So you could think about it like x plus 1/3 twice. However, while this is technically right, you won't see answers written like this, and you would have to rewrite it. And to do so, you'd have to set this equal to 0. Solve for x, so get rid of the 1/3. And then solve it back to get 0 by itself. So I could multiply both sides by 3. And then to make this 0, I could add 1 to the other side. To get that factor that we just found. And then you could write that twice, 3x plus 1 in parentheses squared, or 3x plus 1, 3x plus 1. But you would miss some of the work. You could go back and try to do that work or work backwards, but you would need to show the rest of that work as well. Questions on that? Yes?
I'm a little bit confused why you're allowed to multiply everything by 9.
Math rules, as long as you're doing it to everything, you can do that.
Okay.
If you multiplied it by something that wasn't 9, you're just going to end up with more fractions. You want to try and get everything to be a whole number. Yes.
Okay, wait.
So somewhere else where you have space, write down this one in purple. W squared minus 7/3 W plus 49/36. And I'm going to let you guys try that one on your own, but I can come around and check it. Only multiply, now you could multiply by the entire fraction flipped, but you really just need to get rid of the 36. So multiply everything by 36. That'll be your hint to solve that. Once you finish that, get it checked. And then you guys can, I'll put 2 more up, and you can either try those, work in your notes, work on Delta Math. There are 2 that are due. I think 1 is due this week, 1 is due next week. I have to double check that. JLabs, missing Delta Math, SOL practice. So do that one first, get it checked, and then you have a bunch of things you could be working on.